still in the process of sorting everything out, but we've established that in the time interval delta t, the change in the amount of solute, which I'll write as delta q, is q of t over v times r delta t. And I asked what's the rate at which the amount of solute changes, and I thought it was implicit, but it wasn't. Then when I asked, well, what's it changing with respect to? Well, with respect to the rate at which you're putting stuff in, no, that rate is constant, okay? A rate of change is a change in this quantity divided by a change in this quantity, and if you try to do with respect to the rate at which stuff's flowing in, that's not changing, so you'd have a denominator of 0, okay? So that was a good try, but wasn't the best answer. So I said, okay, it's the rate at which it changes with respect to time. And that is delta Q over delta T. So delta Q is what we just found up here, and it took us a while to discover that because I didn't have this delta Q equal. That is why we did all this, so we would know how much change there is in the amount of solute. If we then divide the delta Q, which is this, by the delta T, which is the time during which that change occurs, we get the rate of change of the amount of solute with respect to time, or at least an average rate over a short time interval. And we take a limit as delta T goes to 0, and we find that this relationship, which of course is written down by writing this and then dividing by delta T. Come on in. Don't worry about the camera. You won't break it. Okay. The change in the amount Q divided by delta T is just going to then be this. Very easy to see. And then I can say, well, we take the limit as delta T goes to 0, and we find that dQ dt is just R over V, the rate of inflow per unit of volume of the container, multiplied by how much solute is in there. And now we have a very simple differential equation that we can quickly solve to get the function, and it turns out to be an exponential function. Confused again?
Wait.
I'm glad we got good videos. Now, I almost did the same thing. I almost came at the physics time.
Oh my God, today's Thursday.
Yeah. I checked the snow schedule and realized, oh my God, I better hurry. Okay? Still had time, so it was okay. Okay, well, you know, anyhow, we got good videos. I don't have time to show you what we did, but I'll show you in the lab tomorrow. Okay, anyhow, we have this, right? So we get this equation that we can easily solve, and we're going to get Q as an exponential function. So the amount of Dr. Pepper in our cup, as we pour water in at a constant rate, decreases exponentially. You get an exponential function, which my pre-calculus class will get to see in another month or so. But they won't have to solve a differential equation to do it. Okay.